Hello everyone. Today we will be learning methods of disinfection. In the earlier lectures we saw various methods of disinfections. They were boiling, treatment with excess lime, treatment with ozone, treatment with ultraviolet rays, iodine and bromine treatment, silver treatment, potassium permanganate treatment, and chlorination. Chlorination also we had a brief idea. Now we will be discussing chlorination in detail. Now chlorination used as a chlorine is used as a disinfecting material as it is easy to apply due to relatively high solubility of water or solubility of 7000 mg per liter, readily available as gas, liquid or powder, very toxic to most of the organisms, microorganisms. It is cheap and reliable. Chlorine can be applied in water in one of the following ways: as a bleaching powder, as chloramines, or as free chlorine gas. Mechanisms of action is water reacts with chlorine and we get hypochloride ions, and hypochlorous acid. Okay. Now the disinfecting action of chlorine. How the chlorine reacts. Okay. Chlorine gas hydrolyzes rapidly in water to form hypochlorous acid. The hypochloride ions may further combine with water hydrogen ions present in water so that hypochlorous acid is formed. Now, disinfecting action of chlorine. Between a pH of 6.5 and 8.5, this dissociation is incomplete and both hypochlorous chloride ions and calcium hypochloride species are present to some extent. Below a pH of 6.5, now no dissociation of hypochloride, calcium hypochloride or hypochlorite ions are found. While it occurs above a pH of about 8.5, complete dissociation of hypochlorite ions are there. As the germicidal effect of calcium hypochloride is much higher than hypochlorite ions, chlorination of lower pH is preferred. Now we have seen the theory how the chlorination occurs for the germicidal effect of water. For now various forms in which chlorine can be applied. How chlorine will be applied so that it will kill the germs which are present in water. Chlorine may be applied to water in any of the one form, in the form of liquid chlorine or in the form of gaseous chlorine, in the form of bleaching powder, in the form of chloramines, or in the form of chlorine dioxide. So we will be learning one by one in the further lecture. Now chlorine, use of chlorine as liquid or chlorine gas. The molecular chlorine can be carried and applied to the water to be treated either in the liquid form or in the gaseous form. The liquid form is generally preferred and almost exclusively used these days. The gaseous form of chlorine gets converted into liquid form when subjected to a pressure of 700 kilonewton per meter square. The liquid chlorine is kept in steel cylinder under a pressure of 700 to 1000 kilonewton per meter square. When required for use, the pressure is released and the liquid chlorine gets converted into gas, which escapes out of the cylinder and dissolved in water to make a solution in the chlorinator. Chlorinator is an instrument which is used to treat chlorine. Chlorine is applied to the water to be treated through an instrument which is called as chlorinator. Supply cylinder is generally kept at about 38 to 42 degrees to prevent the freezing of liquid chlorine in the cylinder. Okay, I told you that liquid chlorine is most extensively used these days. So what are the advantages of liquid chlorine? Why do we prefer liquid chlorine? It is quite cheap and easily available. It can be easily stored for longer period without any risk of its getting deteriorated. It occupies less space for storage. It can be easily and cheaply transported. The chlorine dose to be added can be easily measured. It can be uniformly applied to the entire body of water. No sludge is formed in its application, as may be formed by using chloramines or hypochlorite or any other methods. Now, gaseous chlorine. A brief idea regarding that is gaseous chlorine should not be applied directly because there is possibility of corrosion in pipes and fittings due to the accumulation of undissolved gas. Chlorine gas may not fully diffuse in water. Chlorine cannot be fed in pipes above 1.75 to 2.1 kg per centimeter square pressure. At low temperature, there is possibility of chlorine concentration around the diffuser. So, all this was regarding liquid chlorine and chlorine gas. Now, the next use of chlorine is use of hypochlorite as bleaching powder. Okay, hypochlorites of calcium and sodium may be used for chlorination of small public supplies, private industry, colony or estate. When hypochlorites are added in water, you can see that calcium hypochlorite reacts with water and calcium ions and hypochlorite ions are formed, and hypochlorite ions may be further combined with hydrogen ion present in water. Here you can see that the chemical reaction and hypochlorous acid is formed. Now the process of chlorination with hypochlorites is known as hypochlorination. Okay, the bleaching powder is a white powder. Bleaching powder is a white powder. Normally everybody might be knowing regarding that. It contains about 30 to 35% of active or available chlorine. It is very unstable compound and hence it requires very careful storage. This it goes on losing its chlorine content when exposed to atmosphere. It requires quite the required quantity of bleaching powder in is dissolved in water to form a concentrated solution of it. This solution is then added in the required quantity to the water to be disinfected. Okay, the usual quantity of bleaching powder requires for normal water is about 0.50 to 2.50 kg per million liters of water. Advantages of using this method is that they are available in powder form in small packagings. Their chlorine content does not decrease with storage. They can be applied to water in dry condition or as a solution also. Now use of chlorine dioxide. Okay, we saw two methods. Use of chlorine, we saw three methods: use of chlorine as liquid, use of chlorine as gas, use of hypochlorite and bleaching powder. Now use of chlorine dioxide. Now chlorine dioxide gas ClO2 is very effective and powerful disinfectant. It is about 2.5 times stronger than chlorine. It when sodium when it is produced by chlorine gas through sodium chloride. Okay, it is produced by passing chlorine gas through sodium chloride. The chlorine dioxide gas is costly and very unstable and has to be used immediately after its production. Okay, for these reasons it is generally not used for treating ordinary public supplies. However, it may be used for treating waters containing large amounts of organic impurities. Since the action of chlorine dioxide remains unaffected by the high pH values, it can be advantageously used for treating highly alkaline water with pH between 8 to 10. Here I will tell you that when the pH is pH of water, that means when high alkaline waters are there, that is the pH is ranging from 8 to 10, we can use chlorine dioxide gas. Okay, the normal dose of chlorine dioxide gas usually ranges from 0.5 to 1.5 mg per liter. Now, in the coming lectures, we will be learning the other applications of chlorine.